A bar magnet of length L and magnetic dipole moment M is bent in the form of an arc as shown in the figure. What will be the new magnetic dipole moment? We are given the original magnetic dipole moment, which is nothing but capital M of a bar magnet, and it is defined as M is equal to M into L, where small m is the pole strength and L is the length of the bar magnet. When the bar magnet is bent into an arc of 60 degrees, the effective length between the poles changes. Since the magnet forms an arc, we need to determine the effective distance between the poles along the arc. For a 60-degree arc, the arc length L arc is proportional to the central angle, making the effective length of the magnet along the arc. So we get L arc is equal to pi by 3 r, where r is the radius of the arc. The magnetic dipole moment of the arc will be proportional to this new effective length. Given that the original moment m corresponds to a length of L, the new dipole moment m mu can be found by adjusting for the arc length proportionally. So we get m mu is equal to m into 2 by pi. Thus the correct answer is indeed option A, 3 by pi m.